Now that we know the difference between heat and temperature and we know what specific heat is, we can now start solving problems using these concepts. The main equation we're going to use is the heat equation. This equation takes the form Q equals CSP m delta T. What do these things mean? Well, Q is the heat, CSP is the specific heat, M is the mass, and delta T is the change in temperature. The units are joules for heat, joules per gram degrees Celsius for specific heat, grams for mass, and either Kelvin or degrees Celsius for change in temperature. The reason why you can use both is because it's a change. Kelvin and degrees Celsius have the same size in their degrees. A degree Celsius is the same change in temperatures as a Kelvin degree, so we can use either. This triangle means change. It's the Greek letter delta, and delta T is actually an equation in itself. Delta T equals T final, the final temperature, minus T initial, the ending temperature. When we solve a problem using this equation, we're usually looking for how much energy is released or gained when the temperature changes, or how much energy is needed to change the temperature by a certain amount. We can also find the specific heat of an unknown object, and we could determine its mass if we knew the other variables. Here we have a sample problem. 1,068 joules are released from 10 grams of an unknown substance. If its temperature changes from 60 degrees Celsius to 30 degrees Celsius, what is the specific heat of the substance? So what we're going to use is the equation, and we'll make a list of variables. So the variables needed are Q, CSP, M, TF, and Ti. Looking at the equation, it says 1,068 joules are released. Well, joules are the unit for Q, heat, and it says it's released. So if this amount of energy is released, the object is losing the energy, so it must be negative. So Q will be negative 1,068 joules. So be careful of that. If our object is releasing energy, it will be negative. If it's gaining energy, it'll be positive, or absorbing energy. Specific heat, we don't know. The mass is 10 grams. The final temperature, what we end at, is 30 degrees Celsius. And the starting temperature is 60 degrees Celsius. And just as a side note, words such as released, lost, those mean a negative Q, because heat was lost. If you have words like gained, or absorbed, or added, you have a positive Q, because energy was added to your substance. So back to the problem, we'll plug in the numbers. Negative 1,068 equals specific heat times the mass times delta T. T final is 30 degrees Celsius minus the initial temperature, the starting temperature, 60 degrees Celsius. We'll simplify this so we get negative 1068 equals CSP times 30 minus 60 is negative 30 times 10 is negative 300. Solve for CSP and we get 3.56 joules per gram degrees Celsius. Note, specific heat must be positive. This means if you got a negative number here, you did something incorrect. So go back and check your order of your T final and T initial, as well as whether your energy should be negative or positive. But specific heat must be positive. So we get 3.56 joules per gram degrees Celsius, and this is actually really useful. If we look at our specific heat table, we can see that the substance that has a specific heat of 3.56 joules per gram degrees Celsius is lithium. So we actually identified the identity of the unknown substance by finding its specific heat. So we can identify substances using specific heat. Let's look at one more sample problem. So here we have an object that has an initial temperature of 35 degrees Celsius, its mass is 14 grams, and it has a specific heat of 0.45 joules per gram degrees Celsius. If it absorbs 2056 joules, what is its final temperature? So we'll make a list of our variables. Q is going to be 2056. Because it is absorbing this energy, it's going to be positive 2056 joules. Specific heat in this case is given 0.45 joules per gram degrees Celsius. The mass is 14 grams. The final temperature we don't know, but we know its initial temperature is 35 degrees Celsius. We set this up. So what I have to be careful with is I need to show T final minus T initial, and I need to make sure the 35 goes in the initial spot because that's the starting temperature. So when we start to solve this, we end up with 326.3 equals TF minus 35. Notice that you have to simplify everything else before you solve for TF because we have multiplication here, but here we have subtraction. So we have to multiply these together and then divide on both sides to get 326.3, and then we add 35 to both sides, and we end up with a final temperature of 361.3 degrees Celsius. So we've had a big increase in temperature, and we've solved for TF. Next, we're going to look at how do we identify unknown objects if we don't know how much heat was absorbed or lost.